Hola, 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 hola. Probando. 1, 2, 1, 2. Probando. Okay. Let me move the camera a little bit to the right side, left side. Okay, perfect. And let's going to continue with the theorems. Okay, guys, let me draw the picture of the in-center theorem, and I'm going to explain what does that means. Okay. Perfect. Jesus. I'm missing one
Gracias,
single.
mister.
Thank you, thank you, thank you so much. Oh, that's deception. Over here, that one. Better. Como les decía en la clase anterior, lo más complicado de esto es dibujar el triángulo y no tanto la resolución del problema. Okay. A, C, E. A, E, C. A, E, C. D, B, F. D, B, F. And we got the point B. And this is going to be a black point. I'm going to use the black one. All right, excellent. Yesterday, guys, we were talking about the, sorry, let's see, yeah. Yesterday, we were talking about according to the bisectors of the angles. And remember, we established what will be the definition of the intersection of different lines in one singular point. Just for a little reminder, or a little review, remember the intersection point. When we have three or more lines that intercept in one singular point, the name of that situation or the name of those lines that we're talking about will be concurrent lines. And the point we're going to receive the intersection of all of these lines as a singular name is a point of concurrency. Okay, and remember, we explained already yesterday the triangle has a geometric shape of three sides. Okay, for that reason, we're going to have three bisectors. Okay, three perpendicular bisectors, and the name of that we're going to these three lines, these concurrent lines, bisectors, going to intercept in the concurrencing point. And this concurrencing point, yesterday we're talking about is the circumcenter of the triangle. Is the another way of saying is the point of concurrency of a triangle in simple merely words. Hold on a second. Okay. And the name of that intersection point, the point of concurrency is the circumcenter of the triangle. And we established already, right? Because this is a circumcenter of the triangle, the size of the triangle will be congruent, okay? And singular merely words. Now, let's going to talk it about with the incenter. In the incenter, as soon as you can see, it's almost the same postulate of the triangles. What will be the difference? Well, the difference is the incenter means are the lines which divide the angles into equal parts. For that reason, if the circumcenter established, the size will be congruent every time that we're going to form one singular triangle. Well, in the inner center, is the points obviously intercepts the lines, but they split the angles into similar parts. Okay, this is the difference between a circumcenter and inner center. Inner center divide the angles into equal parts. In circumcenter, the length of the triangles they're creating in one the interconcurrency point will be congruent. This in simple merely words what the problem talking about. Okay, and remember yesterday we mentioned the how we can draw the circumcenter. The point of circumcenter could be in the interior of the triangle, could be in one side of the exterior of the triangle, and could be in one side of the triangle. Specifically, if we have an AQ triangle, remember AQ triangle, the triangles that's supposed to be less than 90 degrees. So one single example could be the equiangular triangle, 60, 60, 60. In that situation, the circumcenter will be located inside the triangle, the interior of the triangle. The obtuse triangle, remember, at least one of the triangles that's supposed to be superior than 90 degrees and less than 180 degrees. Okay, and that point of concurrency, in this case, the circumcenter, will be located outside the triangle, I mean the exterior part. And, in the circumcenter of the triangle, when we're talking about the right triangle, you know, one singular right angle, that will be located uh, in one singular side, in this case, in the hypotenuse of the right triangle. Okay, so according to this situation, let's going to try to solve one singular problem. Okay, one single example. Remember, this is not complicated example, but the most complicated thing in this situation, guys, to tell you the truth, is create the triangle. Okay, so let me give you the example number one. And the example number one mentioned, chon, 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 chon. Find each measure if S, find each measure, find each measure if S is the incenter, is the incenter of triangle M and P. And what measure we're talking about? Letter A, they're asking for SU. And the letter B, they're asking for what will be the measure of the angle SPU. Measure of the angle SPU. All right. And I'm going to drop the picture of this triangle. Okay. This is going to be the triangle MPN. Okay. And according for this case, the circle center will be located over here. All right. And let's, well, actually a little bit longer over here. And let's draw the intersections lines. Vamos a ver, no, un poquitito más abajo era este. Aquí es mejor. Okay. And now the intersection lines. We have a one intersection line here. We have another one over here. Okay. We have another one over here. And obviously we have another point here. This is going to be the point U. This is the point U. This is the point U. We have the point T. This is the point T. All right. T, U, all right, and R. I'm missing the point R. This is the point R. And the middle one, this is represent the point S. This is the point S. Just to explain you already, is the hardest part in this problem is trying to draw the triangle because it's a little bit complicated, but after that, there's no problem. We have a right angle over here, right angle over here. Well, actually over here, that one, but in both cases, it's the same. Right angle, and we have a right angle over here. And how about with the measures, the given triangle? We have 8 units over here. This is going to be 10 units. All right, A10. Okay, 31 degrees over here. 31 degrees. And also we got 28 degrees. All right, we'll fulfill the problem. Now it's time to trying to looking for what the problem is asking for. Okay, the problem says, all right, guys, find that each measure if S is the incenter of the triangle M and P, and we're supposed to looking for what will be the measure of SU, like for a given example. And after that, let's going to focus in the triangle. Okay, guys, what is the keyword of the moment we're trying to looking for the measures of the sides in the inner center and circumcenter of the triangle? It's simple. It's identify what the problem asking for. Well, problem says we have to looking for the mile as the mile, actually the segmental line as U located over here. If you see, we have a one singular right triangle. This right triangle, as soon as you can see, according to the theorem, this triangle will be congruent with the second half over here because this line intercepts is the midpoint of the line NP. For that reason, these two triangles will be congruent. Basically, what will be the strategy in this situation? If you wish, the strategy will be trying to draw this right triangle formed by the S, U, and P. Will be easier for you at the moment going to establish what we have to do. You can do it with the purple marker or another color using the pencil, whatever you want. Okay, so to give you an example, we have the hypotenuse located over here. We have the right angle. Yes, I'm going to do it just like this one. Okay, and we have this extension. I'm taking outside this expression this triangle, all right? And I'm going to draw the vertices. What will be the vertices? This is going to be S, U, and P, okay? And what will be the distance between S and P? Well, the distance between S and P, as soon as you can see in the problem, will be 10 units, and this is a right triangle. How about with the distance between U and P? Well, we have 8 units. Okay, so the problem asking for what will be the measure of the side as U, the distance for that situation. All right. So if you wish, right, we can add like what a variable if you want. We can establish a distance x. Okay. If you want to apply one similar situation. And because this is a simple right triangle, we can apply the Pythagorean theorem. Remember what the Pythagorean theorem established. Remember, Pythagorean theorem established the square of the hypotenuse will be equal to a squared plus b squared. Well, we can say the letter A could be the shorter length, the letter B, the middle one, and C, the highest one, the hypotenuse. Remember, the hypotenuse is the side of the right triangle who's located just in front to the 90 degrees angle. So simple merely words, we got 10 squared equals the value from 8 will be x squared. We don't know what value it is, plus 8 at the second power. What we're going to do, simple, 10 at the second power will be 100. Subtract 64 because 8 at the second power is 64. The answer for x squared will be 36. But because we are not looking for x squared, we are looking for only the value from x, we can conclude x equals 6 units, okay? This is going to be the first answer. The first answer. Remember what will be the measures of SU? All right, we're going to say This is going to be 6 units. All right. How about the second one? We have to try to looking for what will be the measure of the angle SPU, 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 SPU. Remember, the middle one represents the position of the angle. In this case, they're asking for what could be the value of this angle theta, right? Because the problem says what will be the measure of the angle SPU. Remember, the middle one represents the position of the angle. Yes, Maria Fernanda, go right ahead.
Mister, how do you know that that is the formula to use to find SU?
Simple, because we have a right triangle. This is a right triangle, right? And remember, we have a right triangle, we have the longest side. Just look at in front of the right angle is the hypotenuse, and the distance between U and P is the base. But the reason, remember, if you are trying to looking for the measure of the one side of any right triangle is by means of Pythagorean theorem. That's why. And if you see the picture, SPU has the right angles. The only thing that obviously I'm not drawing in that same position, but I'm taking outside this right triangle just for a representation of what we're looking for. But every time that you have a right triangle, you have to looking for one singular side. If you have two sides, you must use the Pythagorean theorem. So in this case, the problem asking for what will be the measure of the angle SPU. Well, yes, Jorge, go right ahead.
Mister, and what if it wasn't the right triangle?
Excuse me?
What if it wasn't the right triangle?
How do I know what's a right triangle? Because
No,
we
if
have,
it wasn't the right triangle, how would you get the side?
okay, in that situation, no, always we're going to have a right triangle because remember, we're talking about perpendicular bisectors. And always the perpendicular bisectors has an angle of 90 degrees. Don't worry about it. Remember the postulate. The triangle has a three sides, okay? And because the triangle has a three sides, always we want to have three perpendicular bisectors. What are the perpendicular bisectors? Obviously, this one, and that one. And for that reason, always we're going to create right triangles, all right? Okay, there's no way we don't have a right triangles. Understood?
Yes.
All right, don't worry about it. Always, 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 we're going to have right triangles because we're talking about perpendicular bisectors. Now, I have a question for you. In this case, we have to looking for what will be the measure of this angle. All right, so we have this situation, okay? We must to find out what will be the measure of the angle SPU. Remember, we have this case, the three sides of the triangle, and we're looking for the angle theta. If you remember, last year, we studied the three trigonometric ratios, sine, cosine, and tangent. Remember the using the words, the anagrams words, so, ka, toa. So katoa, we learned this trigonometric ratios last year in algebra 1. So katoa S, C, and T, what does that mean? The letter S represents the function of sine of theta. Remember, sine of theta represents opposite over hypotenuse. Cosine theta represents the adjacent over hypotenuse. And the third one, we can use tangent theta will be opposite over adjacent. All right. In this situation, this is the trigonometric ratios formula that we're supposed to use last year. In this right triangle, remember we have the measure of the three sides, 10, 8, and 6. And the problem asking for, we must find out what will be the angle theta. Yes, Jorge? Yes, Jorge?
No, I just forgot to lower the hand.
Okay, don't worry. So, in which, because we have the three sides of the triangle. It doesn't matter which one of the techniques, sine, cosine, tangent we can choose. At the end, the answer will be the same because we're looking for the value from the angle. So which one would you like to use, sine, cosine, or tangent? Sine, cosine, or tangent. ¿Qué lado, qué fórmula le gustaría utilizar de SOHCAHTOA? ¿Seno, coseno o tangente? Aquí no importa cuál de las tres use, al final da lo mismo porque ya conocemos los tres lados del triángulo. All right, I'm going to choose sine of theta. Okay, remember, sine of theta is given by opposite over hypotenuse. When I said opposite, remember it's the side whose approaches or just is next to or just in front of the angle that we're looking for. In this case, 6 is in front from theta. For that reason, 6 is the opposite side. And what will be the hypotenuse? The hypotenuse will be the side who is located just in front of the right angle. That will be 6 over 10. And because we're looking for what will be the value from theta, it's simple. Arc sine of, well, actually we can simplify this expression. Have 6 is 3, okay? Have 6 3, and obviously, have a 6 3, have a 10, it's 5. So guys, I really need your help. What will be the arc sine? I require your calculator. What will be the arc side of the value 3 feet? What will be the arc sine of 3 feet? Please. Por favor.
36.86.
36.86. Okay, we can give them like a 36.9 degrees. Okay, and this is going to be the angle that we're looking for in this situation. All right, and this is how we're going to solve at this, the first example. Don't worry about it. Always we're going to have right triangles because we are studying perpendicular bisectors. In particular, bisectors give us always gave us the, how to explain you, always gave us the perpendicular angles. That's why. All right, I'm going to move the camera. Just, I don't know if you did you copy that already. This possibly, I don't know, may I change the camera view? ¿Puedo cambiarlo o todavía no? ¿Puedo cambiar la cámara? ¿La vista de la cámara?
I'm just missing a little bit, Miss.
Okay. Meanwhile, I'm going to erase the second part of the whiteboard and let me know when you finish. All right? Cuando terminen me avisa, ¿vieron? Meanwhile, copy the second problem. Find the measure. Find the measure. Find the measure of triangle ABC. Okay. Letter A, asking for GFG or JF. JF. B angle JIC.
I finished, Mister.
Okay, I'm moving on. JAC. I'm going to move the camera a little bit to the right side. Just to explain you already. The most hardest part in this problem eavesdrop the picture of the triangle, believe me, because you have to pay attention where it's going to be located. The incenter of, we are out of time. Well, I'm going to finish the class on this part. Well, voy a dejar dibujado aunque sea el, déjeme ver, no nos va a dar tiempo. Lo vamos a dejar hasta aquí entonces, no nos va a dar tiempo para dibujar este triangulito. Si Dios lo permite, el lunes vamos a hacer más ejercicios de este. ¿De acuerdo? Entonces recuerden, no se les olvide repasar estas lecciones que vimos el año pasado, de lo que es SOHCAHTOA. Recuerden los radios trigonométricos seno, coseno y tangente. ¿Ok? Bueno, entonces lo vamos a dejar hasta aquí. Dios los bendiga, los guarde, los cuide. Los veo a la hora de física, que hoy vamos a terminar el ejercicio que teníamos pendiente. Cuídense muchachos, nos vemos en Physics. Bye bye, so long, take care of yourself.
Dios.
Nos vemos. ¿Pero entendieron esto hasta ahorita o no? Hola. Hello, digan algo, hombre, ¿sí o no? Bueno, voy a asumir que sí. Vaya.